Good evening, everybody. Welcome to our live stream of the lunar eclipse. Apologies for the sound, it's a little bit crackly. We have with us tonight Stefan Neville, one of the AASV members, the volunteers, who's going to talk to us a little bit about the moon and the eclipse that's happening right now. And while he does that, I'm going to wander through the crowd, and if anyone's got a question, feel free to ask Stefan and he will answer it for you. Stefan, the floor is yours.
That's right. Thank you so much. So, yeah, I'm sure everyone here is sort of aware, but obviously the Earth casts a shadow. You're seeing it right before your very eyes. So just like our own bodies sort of block light from the sun, and we cast a shadow, so too does the entire Earth. And that's what's happening right now. The Earth's always casting a shadow out into space, but there's usually never anything out there to block it so that we can see that shadow. But occasionally the moon in its orbit around Earth will pass just in the right position that it'll pass into the Earth's shadow, and that's what's causing this lunar eclipse. So you can see on the edge here, just on the side that's still pretty illuminated, this is the edge of the Earth's shadow, what we call the penumbra. And as it passes deeper into the center of the Earth's shadow, that portion is what we call the umbra. And right in the center of the shadow, it sounds sort of counterintuitive, but the center of the Earth's shadow is actually the brightest part of the shadow. And that's because some of the sunlight that's passing towards Earth passes through the Earth's atmosphere and refracts, so the light bends towards the center of the shadow. And only the longer wavelengths of light, the red wavelengths, are those that bend and go into the center of the shadow. And so that's why the moon's being illuminated a deep red. It's light that's passing through the Earth's atmosphere. So all of the combined sunrises and sunsets on the Earth are passing into the center of the shadow and illuminating the moon. I think, so there are a couple different types of eclipses. So this is what we call a lunar eclipse. There's also a solar eclipse. You've probably heard of that. And that's where the moon passes in front of the sun and casts a shadow on Earth. That's actually much more rare. So that happens once every few years, but it's only in a very specific area on Earth. It only covers a very, very small part of the Earth. So you have to be really lucky to be in the right place at the right time to see it. But a lunar eclipse like this is visible to the entire nighttime side of the Earth. So everyone all throughout Australia, Southeast Asia, and some of the Americas can see this at the moment. But even though the lunar eclipse is more common than a solar eclipse and kind of easier to see, I still think it's really quite a wonderful event to behold. It's sort of a reminder that the universe around us is in constant motion, you know. We always think of the universe up there as sort of static and unchanging and just this sort of distant alien sort of construction. But really it's an incredible dynamic system, this amazing ballet choreographed by the forces of gravity that have been happening for billions of years, long before humans have been around, and they'll continue happening long after.
So just a question for you from me, because I just play MC, I don't know much. What phase are we in at the moment? Have we discussed that?
So I that's a great question. Yeah. I don't even know if there are particular names given to the different phases of the lunar eclipse. I just know that there's the penumbral part, which is the sort of outer shadow, and then the umbral part, which is the middle shadow. So now you can see that the penumbral shadow is we're just sort of finishing off. So we're almost completely within the penumbra, that dark part. And then the other end of the moon is sort of entering the umbra. That's where it's getting really, really dark and really, really red. So I think there'll probably be another 15 or 20 minutes of this penumbral shadow until we're fully submerged within the penumbra. And what time are we at? So in 15 minutes, that's when we will be at totality. So in 15 minutes, that's when the entire moon will be submerged within the umbra, the central part of the Earth's shadow. And that's when the moon will be its darkest and its reddest. So again, that'll start in 15 minutes at 9:10, and it will last for a total of 15 minutes. So any time after that, from 9:10 till around 9:30, that's a great time to go around, look at the other telescopes, have a look through, and see the moon at its reddest.
Stefan,
Yeah.
we have a question online saying that it doesn't look very red from her backyard, more black-grey. Why is that? Is that because we're not quite into that red phase just yet?
Yeah, so it's definitely entered the red phase. So if you look on the edge opposite the bright edge, that's where it's sort of getting into the umbra, and it's not very, very bright. Like, it's not going to glow a bright red. It's just sort of a very dim red.
We have another one, Stefan. Monica wants to know, how often does this happen?
So on average, lunar eclipses happen around 1 to 3 times per year. So usually, 1, 2, or 3 times a year. But again, you have to be in the right place on Earth to see it. Of course, all the other people on the other hemisphere, during daytime right now, they won't be able to see this.
We're just going to filter through some more comments, and we might have some more questions shortly for you, Stefan. For those who are watching this at home, we hope you're enjoying what you're seeing. This is coming to you live from the Caulfield Racecourse Reserve. Hello to the Mirrabah community. Hello, Sarah from the Mirrabah community.
And just to everyone in the audience live here, if you have any questions at any point, feel free to come up to me and have an ask.
So I think for the moment what we might do with our live stream is just let it sit there for everybody to watch. And as we move further through... Oh, hang on, it looks like we have... Yes, we have a comment there from... Nope, not hello from Lang Warren.
They're going so quick.
And moving all these comments, so many comments. Yes, Belinda, this will be saved to our Facebook and to our YouTube, so your sleeping children will be able to have a look at this tomorrow. So what we might do is just let you enjoy the beauty of the moon. And as we move further in, if we get some more questions... Oh, look at that. SES Sunbury unit. Thank you, AASV, for this great commentary. We're doing our best, and thank you for sharing our stream. It's a wonderful event, and we're so lucky to have been able to hold this event today. That's one that he should ask into the microphone.
Yeah, sure. I've got a question from the audience here. Would you like to ask that into the microphone?
No, what was the question? Do you want to whisper it to me?
Why is the moon much bigger?
Why is the moon much bigger? Is there a reason it's bigger?
There is a reason it's bigger, and that's because the moon, as it goes around the Earth, it doesn't go around the Earth in a perfect circle. It's sort of an oval shape, what we call an ellipse. And so at a certain point, when the moon is going around the Earth, it's closer to the Earth, and at a certain point, it's farther away. So right now, the moon is at its closest point to Earth. So it appears just a little bit bigger, around 15% bigger than when it's at its smallest. So it's a good question.
We had one of those, was it last month or the month before?
Yeah, I think it's around supermoon time now.
Yeah.
Yeah, of course. Do you want to ask it into the mic?
Not actually.
Sure.
No, I don't have.
What? Hang on. Whisper me the question and I'll...
Why do we never see the other side of the moon?
Why do we never see the other side of the moon? That's a very good question.
That is another fantastic question. Why do we not see the other side of the moon? The reason for that
The
is
Russians
because-
have got a space station there, a base. Is that right?
exactly. That's where
Thought so.
that's where the reptilians are. They're hiding.
Oh, the
No.
reptilians. That's right.
Can't say that. I'll get in trouble. No. So that's really a great question, and that's so if you aren't familiar with this, the moon is always showing the same face towards the Earth, and it's a phenomenon called tidal locking. So because the moon has been orbiting around the Earth for so long, for 4 billion years, there are some forces that the Earth exerts on the moon that sort of locks it gravitationally. So now, the moon's rotation, it rotates at the same rate that it goes around the Earth. So it's always showing the same face to us. It's called, tidal locking.
So will we ever see, say if we lived 5 billion years more, will we ever see the other side of the moon?
No, so unless something dramatic happens to the gravitational interaction between the Earth and Moon system, for now, once a body is tidally locked, it's going to stay that way. So unless some... No. So the other side of the Earth also sees the same face. The same face is always facing the Earth, no matter which side of the Earth you're on. And so you can see the other side of the moon, but you have to go out past the moon. So we've got some photos of the other side of the moon, but that's from satellites and rovers and probes that have gone out past the moon, gone into orbit around the moon. And then you can take photos. And an interesting fact is that the other side of the moon actually looks quite different. It doesn't have those big sort of dark patches, those mare, the seas as we call them. The other side of the moon is actually really, really pockmarked with craters all over it. It doesn't really have those larger, smoother surfaces.
So is that because it's our version of Captain America's shield? Is that defensive shield?
Yeah, that's right. So yeah.
We have another question, and the question was, why does it turn red?
Yeah, that's a great question. So the reason that it turns red is because it's passing into the center of the shadow of the Earth. And the only light that's in the center of the shadow of the Earth is the light that's passed through the Earth's atmosphere. And as light passes through the Earth's atmosphere, it sort of scatters around. And you're familiar with this. At sunset, when the sun goes down low in the horizon and it's passing through a lot of atmosphere, the sky can turn an orangish, reddish color. You'll see in the clouds they turn a sort of pinkish and reddish when it's sunset. That's because all of the blue light that comes from the sun is scattered away and only the red wavelengths remain. And so that's what's happening here. The light that's passing through the Earth's atmosphere, all the blue is being scattered away and only the red remains, and it's passing through into the Earth's shadow and illuminating the moon red.
Stefan, we have another question. Sadie's going to read this one out to you.
Sure.
Someone asks if the back of the moon also goes red.
No, the back of the moon is actually completely black right now, and that's because the back of the moon it's at the moon's nighttime. So there's no light on the other side of the moon right now. It's completely dark. Yeah, of course.
Are there certain experiments that you can do or are there certain things that are easier to do?
Yeah, so someone in the audience has asked, are there certain experiments that you can do when it's a lunar eclipse that you can't normally do when it's fully illuminated?
That's a good question.
Yeah, and the answer is yes, sort of. So because the moon is a lot darker right now, if you're taking a photograph of the moon, you can sort of see the stars that are surrounding it. But if the moon was totally illuminated, it would sort of wash out those stars. And so this is sort of true when you're just taking photos, but of course if you're doing an experiment, you can sort of work around that. But what's interesting is when it's a solar eclipse, that's when you can do some really interesting experiments. So a solar eclipse, again, that's when the moon passes in front of the sun and the sun is completely blotted out and dark. And when that happens, you can see some of the stars around the sun. And this was actually a really famous experiment that proved part of Einstein's theory of relativity. So Einstein theorized that gravity can bend light. And his theory came up with a hypothesis that if there are some stars behind the sun's gravity can bend the light of those stars around, and you should be able to see them. Now usually, because the sun's so bright, you won't be able to see those stars. But during a lunar eclipse, when the moon is blocking the sunlight, you can actually see some stars that are technically behind the sun. And this was an experiment that was carried out. It's a famous experiment from, 100 years ago, where they took some photographic images of the sun during a solar eclipse and were able to see some stars that were actually behind the sun, meaning that the sun's gravity must have bent the light from those stars behind it so that they were visible, sort of vindicating and proving part of Einstein's theory of general relativity.
We have another question, Stefan.
So we're wondering if that it's because of its position.
So Astro New Zealand's live stream is showing a blood moon. Is that because of their position? So that's from New Zealand. So New Zealand's already got a blood moon.
Well, so have we. If you look up, it's just about closing in now. So
yes, but they've already got one.
Well, I think we're definitely looking at the same moon right now. And
would theirs have gone more blood moon earlier than ours because they're further across, it's darker?
No, I can see how you would think that, but no, we're all seeing the exact same moon right now, and no matter which part of Earth you're on, it's going to look exactly like it does now. So if you're in the audience out here, take a look up. We're really getting close to it now. So in about 2 minutes, that's when the moon will have totally passed into the umbra. That last little bit of bright moon will go away and will be in complete red.
We have another question for you. Now Sadie's going to try and read this one out.
So if we have the eclipse in Australia right now, what's happening on the exact opposite side of the world right now?
That's a good question. So if you're on the opposite side of the world, unfortunately you're pointed away from the moon right now. So I know in America they were trying to image the moon as it was setting, so it was just going down. And now if you're in America or parts of Europe on the other end of the world, the moon will have already set. So you won't be able to see it because it's not nighttime over there.
That's fine. We have another one. Another very good question that Sadie's going to read out to you again.
As we know, the moon is slowly moving away from Earth. Will the moon start spinning once it's further out?
That's a really fantastic question. And that's a fantastic question because I don't know the answer. So it's absolutely true that the moon is receding. As the moon is orbiting around Earth, on average, every year, the moon gets around 3 centimeters or 3 inches, I can't remember exactly, a small amount further away from the Earth. So as it ascends to higher and higher orbits, I'm not exactly sure how that will change the rotation of the moon. That's a great question. I'll have to look into that. Maybe you can look into that.
So we've got another one. Is it only Australia that can see the eclipse, or can other parts of the world see it?
So this eclipse, it's quite funny, has chosen basically a part of the Earth with the fewest people visible to it. So this lunar eclipse is visible to pretty much most of Australia, all of the eastern side of Australia, and then most of the ocean. So if you live on the ocean to the east coast of Australia, fantastic viewing for you. But if you live to the western end of Australia and countries over there, it will have probably already set. But yes, so Australia can see it, Southeast Asia, New Zealand, fantastic. But after that, yep, it's a great show for the fish. Yeah, of course.
We have another one. What's the difference between a solar and a lunar eclipse?
So the difference is which body is being eclipsed. So during a lunar eclipse, the lunar moon is being eclipsed. So the Earth is passing in front of the sun for the moon. So the Earth's shadow is going on the moon. During a solar eclipse, the moon is passing between the sun and the Earth. So the moon's shadow goes onto the Earth.
We have another one. How close is the moon to Earth at the moment?
Boy, oh boy. I'm going to take a rough guesstimate of around about 140,000 kilometers. But let me quickly Google my brain for a second.
Just so you know, that was actually my brother that's asked that question. It was nice of him, wasn't it? While you're doing that, we'll pop up another question.
Okay, so I was very, very not close. 384,000 kilometers. maybe I was thinking in miles.
It's okay, Stefan. We all make mistakes.
So we got another one.
Yeah.
Who was the first person to understand why the moon turns red?
That question is being asked by Alana, who is 10.
That's a fantastic question, especially from a 10-year-old. Well done. So that's a really fantastic question, and I'm not exactly sure how to answer that, because lunar eclipses have been happening for billions of years. As long as the Earth has had a moon, there have been lunar eclipses. So lunar eclipses have been happening throughout human history, and humans have always come up with different explanations why it happens. Of course, back in ancient civilizations, when we didn't really know what the moon was, we thought that lunar eclipses were really bad omens of war and famine and this sort of thing. But as we started developing science during the Enlightenment and the Renaissance after the Middle Ages, and we started understanding that the Earth wasn't the center of the universe, in fact there were things going around the Earth and the Earth was going around the sun, that's when we finally started understanding that, oh, okay, the Earth casts a shadow onto the moon. That's what's really going on.
So Andy wants to know, and this is one you can't answer, and Andy was meant to help us with the live stream. This one's for Lee. Lee, what are the chances of your rig falling over and breaking a few hours before the eclipse? And poor old Andy over on the border of South Australia and Victoria, who was going to help us do the live stream tonight, his rig fell over. He came home to find a telescope on its side and dinted, and a smashed camera. It's never fun at all. I hope your equipment is repairable, salvageable, Andy.
We have another question. Does a lunar eclipse have to happen during a full moon?
Yes, it does. And that's because a full moon happens when the moon is on the other side of the Earth to the sun. So the moon is facing the sun and we're looking directly at its completely illuminated side. So when it's a new moon and the moon is gone around the Earth and it's we're looking towards the sun and we're also looking towards the moon, we won't be able to see a lunar eclipse because the Earth is behind the moon. It can't cast a shadow because the moon's in front of it.
We have another one. Is the red dot next to the moon Mars tonight?
That's not Mars, that's a star. I think I'd win an award if I was able to name that star. But no, that's not a planet, unfortunately. It's just a star. But because the moon is now so dim and it's in the Earth's shadow, we've we have to expose with our camera a little bit more, and so we're able to see some of those background stars. Whereas when the moon was fully illuminated, it was too bright and we weren't able to see those background stars.
We have another question. Do any other planets in the Milky Way have any lunar eclipses? This is by Jacob, and he's 11.
Good question, Jacob. So other planets in the solar system do have lunar eclipses if they have moons. So they won't be able to see the eclipse on Earth, on the Earth's moon, but if those planets, take for example Jupiter, which has 64 moons, but it has 4 very big moons. If you're on Jupiter and one of those moons passed behind Jupiter into Jupiter's shadow, that would be a Jupiter or Galilean lunar eclipse.
Another question for you. We've got a lot of questions coming out here.
I've got it now.
Is there any chance that the lunar eclipse can be a different color?
Yes. So the lunar eclipse, the color that passes through really depends on what's in the Earth's atmosphere at the time. So there have been lunar eclipses in years where there's been a lot of volcanic activity or a lot of bushfires, and there's a lot of smoke in the atmosphere, and that turns the lunar eclipse an even darker red. It's never going to go blue or green or anything like that. It's just going to be in shades of red. But some years it's a lot darker red or black, and some years it's a little bit lighter.
So Sadie's going to ask you questions that she sees on the screen as they
We've
pop up.
got another
Oh,
question.
another question.
What effects do a lunar eclipse place upon us as humans?
That's a good question, and look, I'm a little bit biased as an astronomer. I do astronomy, and astronomy is the scientific understanding of the universe. If you do astrology, and astrology is a belief system, astrologers believe that the position of the celestial body, the moons, the sun, the stars have an effect on human behavior. But really, the science doesn't really support that. Scientists have tried to understand whether the celestial bodies, the moon, the sun, the stars, have any effect on human behavior and human personality, but really we don't see any correlation. I'd say the only effect that a lunar eclipse has on a person's personality is when they look up and they enjoy and they appreciate their special place in the universe and this special event that's happening. But no, it doesn't have any direct effect on our behavior, as far as we know. And so I had another question from the audience. Does the lunar eclipse affect the color of the stars? And the answer to that is no. The stars are much, 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 much further away than the moon is. The moon is essentially our next door neighbor in space. The stars are over in a different city on the other end of the world, right? They are very, very far away. The moon, as we have now learnt, is 384,000 kilometers away, but the stars are on the order of billions of kilometers, much, much further than that. So no, none of the light that filters through the Earth's atmosphere is going to illuminate stars.
We have another question.
So many questions. Oh my gosh.
Is this supermoon affecting the ocean with king high tides in Queensland at the moment?
Yes, I would say so. So if you aren't familiar with this fact, the tides on Earth are caused by the moon. The moon tugs on the Earth just as the Earth tugs on the moon. And because the Earth is covered in a layer of very, liquid, that liquid can flow, and the moon's gravity pulls on the Earth, and some of the water flows towards the moon, and in the opposite direction. And that's what causes the tides. So whichever side of the Earth the moon is on, it's going to be a more high tide. Of course, the sun's gravity also affects the tides. So you can get a something called a super tide, I think it is, when both the moon and the sun are on the same side of the Earth or the opposite side, as is the case right now. So right now, the Earth and the moon, the moon and the sun are on opposite ends of the Earth. So they're both tugging the tides in the same direction, and so you get a super tide.
We've got another question. How did the first lunar eclipse get its colour, and will it be red every time there is an eclipse? This is from Ethan, and he's only 10.
Good question, Ethan. So, I wish I was around to see the first lunar eclipse, but that would have been happening billions of years ago. So lunar eclipses have been happening as long as there's been a moon to the Earth, and for the most part, they've been the same colour, this sort of orangish colour. And that's just because of the chemical composition of the Earth's atmosphere. It scatters the blue wavelengths away, and only the red wavelengths remain to pass through towards the moon. And unless something really dramatic happens to our atmosphere, which I hope isn't the case, it'll always remain this way.
Do you know what I like the most about that? He's only 10, says the 8-year-old relaying the questions.
Yeah, yeah.
We've got another question. Is it possible for the moon to leave Earth's orbit?
I hope not. But it is definitely possible for the moon to leave Earth's orbit if something catastrophic happens. So there are many other bodies out there in space, and there are some very large bodies, large asteroids, and if a large asteroid were to go undetected and somehow, against magically low odds, strike the moon, it could potentially knock it out of its orbit. But I think you wouldn't want to worry about that because we wouldn't be around for long after.
We've got another question. Does a lunar eclipse change the temperature on the moon?
Yes, it does change the temperature on the moon. So the moon, as cold as it is out here tonight, it's definitely nowhere near as cold as the moon. The moon can get down to basically absolute zero, around minus 300 degrees Celsius. Absolutely freezing, because it has no atmosphere to retain heat. So on the nighttime side of the moon right now, it's around negative 270 degrees Celsius. But on the sun side, the illuminated side of the moon, because that's getting direct sunlight, it can get a lot warmer. But because the Earth is now blocking some of that sunlight, it's blocking some of the heat. And so yes, the lunar eclipse does change the temperature on the surface of the moon.
We've got another question. How big is the moon? Also, Stefan, you can't Google this one.
Let me consult my brain for a second. No, so off the top of my head, I can give a very, very ballpark number. The moon is... I can't give a ballpark number. It's a fraction of the size of Earth, so I'm wanting to say like a third of the diameter of Earth. Let me just look it up.
It's 1,737.1 kilometers.
That's what I was about to say. Yeah, of course. Do you want to ask it into the mic? Yes, so now it is as submerged as it's going to be. So
we have another weird question.
Sorry.
I think they just lost their tower.
I'm not exactly sure. So it is sort of submerged, and I think it's going to come out sort of on the righter hand side, I think. Don't quote me on that.
Quick.
Yeah. So it's sort of arcing through. It's a little hard to visualize in your head, but yeah. So did we have another question?
Yeah, we have a weird question.
I like weird questions.
Is there an alien base in the center of the moon where they are watching us from?
I'm not authorized to answer that question. The answer is I wish. But probably no. So the question from the audience was, are there other objects out there that fit the criteria of being a moon that we can't quite see? And the answer is yes. The Earth actually has another satellite, but it's much smaller. I can't remember, again, off the top of my head. I think it's on the order of maybe a few 100 meters, but it's this little tiny asteroid that is trapped in a perpetual orbit around the Earth. So technically, it is a satellite, it is a moon of Earth, but it's so small that I think even most of our telescopes here wouldn't be able to see it, even if we knew where it was. And if you're paying attention to the live stream and the image, you might notice that that star has gotten a little bit closer to the moon over the duration that we've been speaking. And that's because of the moon's motion through space. So it's slowly moving. I'm not exactly sure if that moon will eclipse that star, but keep an eye on it.
We've got another question.
Just 1 second, I've got a question from the audience. So the question from the audience was, how often do lunar eclipses happen? And the answer to that is on average 1.5 times per year, but you can't have half an eclipse, so the real answer is 1, 2, or 3 times per year. But whether it's visible to you depends on where you are on Earth. So right now, this lunar eclipse is perfectly positioned for Australia, but not the US. But there might be another eclipse this year that's visible from the US and not to Australia.
We've got another question. Would there be gold on the moon?
Would there be gold on the moon? Let's go!
That's a good question. I'm not exactly familiar with the mineral composition of the moon. I know it's mostly rock. But I'm sure that there would be some gold on the moon, yes. Exactly how much and whether it's worth going to mine that, I can't quite answer.
Tell you what, before you ask another question, a couple of the guys down in Geelong are very grumpy because we have clear skies and it's cloudy down there. Poor buggers. I think Geelong and Warrnambool are the only two places in Victoria with clouds at the moment, so from what I can read. Well, we've got a good night. Have you got more questions, have you, Sadie?
Yes, we've got a lot more.
I like to hear that.
This is an awesome one.
So a 9-year-old is asking if there was ever an astronaut on the moon whilst there was a lunar eclipse.
What would he see? Yeah, so he would be seeing a solar eclipse. So the Earth would be passing in front of the sun. So if he was on the moon looking up at daytime and he was looking at the sun, he would see the Earth passing in front of the sun and it would be dark for him. And if you're paying attention, have a look at that little star down the bottom left-hand side of the moon. It's definitely getting closer. So we're about to see a little stellar eclipse. The moon is going to pass in front of that star. And that's actually the motion of the moon as it orbits around the Earth.
We've got another question. Could you see the reflective markers that were left on the moon after the moon landing if you had a strong enough telescope?
Yeah, so the answer to that's yes. So if you're not familiar, some of the previous lunar missions in history left some reflective surfaces on the moon so that we can shoot laser beams up there, and when we record the laser beams return, that can allow us to so we can shoot lasers up at that reflective surface, and when they come back we can make very, very accurate measurements of the distance to the moon. And that's how we found out that the moon was receding. So if you had a very, very powerful telescope I'm not actually sure. Those reflective surfaces are very, very small, less than a meter. So you would have to have a very, very high resolution space telescope to be able to resolve that. Probably not, or definitely not from Earth, because the Earth's atmosphere will blur out the image and you won't be able to resolve something that small.
We've got another question. What would happen if the whole moon turned bright red? This is from Riley, and she's 11.
Good question, Riley. So, if the moon started to generate its own light, I would start to be very, very worried. But, so if you look up now, the moon isn't generating any of its own light. That's just light that's coming through the Earth's atmosphere and falling onto the moon. So this is about as red as it'll get. And if it starts glowing, run.
We've got another question. Do we currently have any sensors on the moon that transmit information back to Earth from my 10-year-old daughter, Sahara?
That's a really good question. And I think the answer, I'm not exactly sure, but I think the answer is that there are no actively transmitting pieces of equipment on the moon. So there are, like we said, some reflective surfaces that we can still use, and even you can do it. There are tutorials on YouTube showing how you can detect those reflective surfaces, but I don't think there are any pieces of equipment that are actively transmitting from the moon. The last time that we sent a manned mission to the moon was in the 70s, but I know there are some rovers, particularly there was one from China that was sent up quite recently in the last 5 or so years, and that's submitting and transmitting data. And there are some orbiters, so probes that we've sent into orbit that are going around the moon that do transmit data to us. So for example, the Lunar Reconnaissance Orbiter. So this is an orbiter that's zooming around the moon and taking really, really close-up photos and really, really detailed measurements of the surface of the moon. And that is transmitted back to Earth for scientific purposes.
So, Stefan, I've quit for the night. I'm going to the pub. Sadie's taking over.
Sounds good.
We've got another question. Are the people from the International Space Station see the red moon? I'm 9-year-old and my name is Mantiji.
Very good question. So we actually had that question from the audience as well. So if you were on the International Space Station, would you be able to see this? And the answer is yes. So the International Space Station, if you're not familiar, is a space station that's in orbit around the Earth. It's 400 kilometers above the surface of Earth, and because it's relatively close, it has to be zooming around really fast. So the International Space Station goes around the Earth, I think 14 times per day. So if you're on board that, when you go around onto the nighttime side of the Earth, and you could look up, you would see the moon, and you would see this lunar eclipse happening right now. Yeah, so that's a good question. We've got one from the audience. So he's asking, why is this time it's red, and sometimes when there's a lunar eclipse it's not quite red? And that's because sometimes the moon passes right into the deepest part of the Earth's shadow, the umbra. That's where it starts to be red. That's what we call a total lunar eclipse. That's what's happening right now. But there are times when it doesn't pass into the center, it just passes out on the edge, the penumbra, so it's called a partial lunar eclipse. So it doesn't go into the middle where it's red, it just sort of stays on the edge where it's a little bit darker.
We have another question. If there was a person on the moon right now, would it be really dark? My name is Luke and I'm 10.
Good question, Luke, and the answer is yes. So if you were standing on the moon right now and you were looking up, you would see the Earth passing in front of the sun and blocking out the light. So it would be a solar eclipse if you were on the moon. So it would start getting very, very dark.
We have another question. Is it bad for your eyesight?
No, the answer is no. You can, so the moon only reflects around 10% of the sunlight that lands on it. So even when it's a full moon, you can look up at the full moon and it won't really do any damage to your eyes. If you look through one of our big telescopes at the full moon, it can be pretty bright and hurt your eyes, but it's not dangerous to look at the lunar eclipse. It's dangerous to look at the solar eclipse when you're looking at the sun, because the sun is very, very bright and can damage your eyes. But this is totally fine.
We've got a very serious question here. Hi, if astronauts go to the moon and eat cheese...
No, do they go to the moon?
Oh, do astronauts go to the moon and eat cheese?
You know, I'm sure that someone took cheese up there as a joke, for sure. And if they didn't, it's a missed opportunity.
We have another question. Do you think we will ever have a human colony on the moon?
My answer is I really hope so. So it's been quite some years, I think since the late 70s or maybe 80s, that we sent the last manned mission to the moon. But NASA is actually planning an upcoming mission to the moon in the next, hopefully, decade that happens. Now, that's not going to be a permanent mission. They're going to go there and come back. But hopefully, eventually, in the next 50 years, hopefully, we will send some people there to start setting up a lunar colony. Those people will probably start coming back, but they will hopefully start setting up some accommodation or something to start farming materials on the moon, and that will be the seed of humanity on the moon. And hopefully one day, it'll probably be after my lifetime, but hopefully one day the first lunar baby will be born, and that will really be the start of the human colony on the moon.
We have two questions that are the same. Why is one side darker than the other? From Hunter and Charlotte.
Good question, guys. So the reason is that one side of the moon is really deep into the Earth's shadow, and one side is sort of still off in the edge of the shadow. So it's not, the moon isn't going totally right into the middle of the shadow. One part, the dark part, is more in the middle of the Earth's shadow, and the other side is sort of trailing the edge of it.
We have another question from a 5-year-old called Grayson. What makes Earth's moon different to other planets' moons?
That's an awesome question, Grayson. And the answer is that it's really, really big. Compared to other moons around other planets, the moon is one of the biggest in the solar system. I think there's only one other moon in the solar system, and that's one of Jupiter's moons that is as big as our moon. So really, we're quite lucky. The Earth's moon is relatively quite big compared to other moons in the solar system. So that's what makes it special. Most of the other rocky planets, so Mercury, Venus, and Mars, most of them either have no large moons or just very small moons. Mars has two very, very small moons called Phobos and Deimos, but they're tiny, tiny compared to our moon. We've got a question from the audience.
How long have we been able to predict lunar eclipses?
That's a good question. So the question was, how long have we been able to predict lunar eclipses? And I'm not exactly sure, but I know that some ancient civilizations, even far back as the Babylonians, were able to predict celestial events with accuracy. They didn't quite know what was going on. They didn't even possibly know that the sun was the center of the solar system, but they knew that these things happened regularly, and by measuring their regularity, they could sort of slowly predict. But as our science slowly started to develop in the Middle Ages and towards the Renaissance, that's when we started making measurements of the motion of the celestial bodies, and we could make very, very accurate predictions. But certainly there were some ancient civilizations, in Persia and in the Middle East and India and China. Lots of these ancient civilizations were doing very sophisticated science and astronomy and were able to make these predictions.
We've got another question. Can you have a lunar eclipse during the day? This is from Winnie Fred, and she's 11.
I have to think about that. Yes. So, yes, but it would almost certainly be setting for you. So it would be at the end of the day when the moon is sort of setting on the horizon. It's still a little bit during the day, but yeah, it would definitely be setting. Most of the time, lunar eclipses are visible to the nighttime side of the Earth. Sorry? Yeah. So
We have another question.
Yes.
Why is it taking so long, and when will it be completed?
That was the question that was just asked in the audience. So the totality is now complete. So the moon has passed through the Earth's umbra, through the darkest part of the shadow, and is now starting to come out. So you can see now the edge of the moon is starting to get brighter and brighter again as it comes out of the penumbra. Yeah.
How do we know what the moon geology is? I know we took some rocks back. Why do we know what the moon is?
Sorry?
Or did we took rocks back from?
We have another question. Why is the moon orange? My name is Josh and I'm 24.
Nice question, Josh. So the moon is orange right now because the only light that's falling onto it is light that's filtered through the Earth's atmosphere. And that light that goes through the atmosphere, all of the blue wavelengths are scattered away, and only the red wavelengths remain and can pass through and are illuminating the moon. So it's a physical phenomenon called Rayleigh scattering, and it's the reason why the sky is blue during the day. Those blue wavelengths of light are scattered around, and during sunset, the blue is completely scattered away and only red remains. And that's what's happening now. The light from the combined sunsets and sunrises around the Earth are illuminating the moon. And so I had a question from the audience. How did we know the geology or the chemical composition of the moon, or how do we know it, and how did we know it before we were able to go to the moon? And so that's a sort of two-parter question. So the main reason that we understand the Earth's geology and its chemical composition now is because we've been there, we've taken rock samples, we take them back to Earth, and we test them in spectrometers. So chemical analysis machines that are able to tell us what elements, what simple molecules it's made of. Before that, I'm not exactly sure. So there would be some spectroscopic techniques that we could use to make measurements of the elemental composition of the moon, but I'm not sure how accurate they would be, and I'm not sure how much we knew before we were able to take physical rock samples.
Say for other planets.
We have another question. Why is my niece so cute?
From Auntie Gabby, who's 26. She's cute because she steals the microphone from her father.
A new permanent MC, perhaps?
Yeah, new permanent MC.
That's not true.
So I had another question from the audience, not specifically about the moon, but following on from the chemical analysis question about the moon. So the question was, how do we know about the chemical composition of some of the planets? And that's a good question. So the 4 rocky planets, Mercury, Venus, and Mars, we can send physical rovers and orbiters to go in and take samples of those planets and measure them with crude spectrometers on board. But the gaseous planets, I think most of the analysis that we do on them is spectroscopic. So we can take measurements of the light that passes through their atmospheres, and the chemicals that make up those atmospheres interact with light in a way that we can measure their interaction and make inferences about the chemical compositions. But we know that the gassy planets, so Jupiter, Saturn, Uranus, and Neptune, most of those, the majority that they are made up of is just hydrogen gas and a bit of helium.
We have another question. Why does our moon not have a name when moons of other planets do?
Yeah, that's a good question. So I think technically the name of the moon is Lunar. But that's kind of boring, so let's find another name.
Do we have any more questions in the crowd? Any more questions up there?
We have another question. Did the astronauts that did the lunar landing bring back real moon dust?
The answer is yes. Yes. So rock samples were taken from the moon and kept in very, very tightly vacuum-sealed chambers, and numerous specimens have been taken back from the moon and are all being held in really, really delicately controlled environments so that they aren't contaminated, so that we, if we find a microbe on those moon rocks, we know that, it's from Earth. So yes, numerous rock samples have been taken from the moon and taken back to Earth and are being kept and tested on constantly. As our technologies improve, we want to keep testing those samples.
We have another question. Is there really no weather on the moon? Does it rain there? This is from Sahastia, and she's 10.
Great question. And yeah, the answer is no. There's no weather on the moon, and that's because the weather on Earth is caused by our atmosphere. So around the Earth, quite luckily, we've got a lot of gas, a lot of oxygen, nitrogen, argon, carbon dioxide. All of this gas is held to the Earth by its gravity. But the moon, because it doesn't have nearly as strong a gravity and doesn't have a magnetic field to shield its atmosphere, it has no atmosphere. Because of that, there's no weather, no wind, no clouds, no rain. It's just essentially a vacuum.
Thank you for coming. I will be leaving now.
She's off. She's gone
Thank
now.
you.
She's going home. I'm not sure if we have any other questions. I'll go and have a look. But we're coming out of the eclipse now.
That's right. So the moon is now emerging from the penumbra of the Earth.
Any other questions?
As you can see, that edge is getting brighter and brighter. And as time marches on, it will fully emerge from the Earth's shadow and be fully illuminated. So I had one question from the audience.
Oh, okay. Yep.
Just about SpaceX's Starlink satellites.
Yes.
So this audience member has heard about SpaceX's infamous Starlink satellites. So these are a number of little tiny satellites that Elon Musk's SpaceX corporation are sending up into Earth's orbit, and these are intended to create a huge web of 60,000 satellites encasing Earth that will be able to transmit internet connections wirelessly to Earth. And his question was about how these affect astronomy. So the audience member had heard that some astronomers were complaining that these satellites are going to interfere with astronomy. And the answer to that is yes. So at night, usually after sunset and before sunrise, when you look up, you might see a star that looks like it's slowly moving. And that's actually an artificial satellite, most likely a communication satellite in Earth orbit. And these Starlink satellites that are being put up, you can see them. And I've seen them before one night when I was out with my telescope, and you see them in a perfect line, one after the other, around 40 of them, just keep going in the same line silently. It's quite a bizarre sight to see. But yes, there is some worry in the astronomical community that these will interfere with astronomical measurements. For astrophotographers like myself, it's not too big of an issue, but for professional astronomers doing like sky surveys and stuff like that, they can absolutely get in the way. They're very, very bright, and they leave bright trails in any image that you're trying to take. So
But
yes.
what about astrophotographers like me? Oh, sorry, we're doing astrovitography at the moment. So we have one last question, and I think we might end things after this last question. Wendy Clare, who is one of our long-time viewers, definitely not a first-time commenter. Wendy would like to know: is there still a slither of light at the base? Is this going to completely go? So when we had that little slither right during the total eclipse, there was still a slither. That didn't disappear, really, did it?
Not really. So technically the moon was within the penumbra by definition, but yeah, to our eyes that sort of it doesn't quite translate, and it did seem quite bright. It sort of just hung on the edge. So this was technically a total lunar eclipse, but this one sort of passed just on the edge. There are eclipses where the moon passes right into the middle and you won't see a sliver, but this one happened so that yes, it was just sort of skirting the edge of the shadow, and so you could still see the remnants of that bright fringe.
Well, I think we're going to pack it up now, close our live stream off in a second. Stefan, thank you very much
Thank
for
you.
adding the comments tonight. Thank you to everybody who came tonight, and thank you to everybody who watched us online tonight. It's been a whole lot of fun, and the clouds have actually started to roll in here now as well, so we've timed it well. We got a very good clear run when it didn't look like we would, and we managed to pull off our largest event since COVID hit.
Beautiful.
Right in the middle of another little moment. So thank you to everybody, and who knows, if we end up in lockdown again, we might have to do some more impromptu live streaming. So follow our page, and thanks for coming. Can I just ask one? You can ask. We've got to ask them.